Hey everybody, this is Larry, this is me going Q4 of the weekly contest 375, count the number of good partitions. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. This one can be a tricky one, but I think I've done similar problems and that's why I'm able to get it this quickly. Got it in about 4 minutes and change, and I spent some time testing because I was just unsure that I'm going to get it right. It's a little bit YOLO in that regard. But yeah, the first thing to notice is that n is 10 to the 5th. You might have some ideas about dynamic programming, longest path in a DAG, stuff like this. But of course, given that it's 10 to the 5th, that's not possible. The second thing to notice is that because basically another way of saying this is that all the numbers have to be, oh yeah, I guess another thing is that the range are big, so you can do stuff with the size of the alphabet. Just a quick note. But yeah, if you have two numbers, or if you have one number that appears in two places, what does that mean, right? That means that, what that means is that they all have to be within the same partition, right? So if there's a 1 in the first element and the 1 in the last element, it doesn't matter anything else. It just has to combine, right? Like, that's just by definition, because if they have to be in the same partition, and therefore everything is in the same partition. And in that way, you can kind of think through the logic a little bit. And then now, like if you have 1, 2, and then a bunch of other stuff, I'm just banging on the keyboard, a bunch of other numbers. And then now you have another 1, and then you have another, and then another 2. Well, you can think that, okay, well, for this one, like just logically in English, this one has to be in, these numbers all have to be in the same partition, and these numbers all have the same these numbers all have to be in the same partition. So then that means that you have two overlapping partitions that has to be together, so then you can merge them into one, right? So that's basically the idea, is merging these intervals. And I think there's a variation of this problem, maybe even on Leetcode, I don't remember, but I remember solving it, where it is the alphabet, like A to Z, 26 things. So now you have 26 segments, and you just do a merge segment on them, and you could even be expensive on the merging, and it's fine. But on this one, it's not as easy, right? So yeah. So the idea here is the core idea for this one, solving this one in linear time, is going to be what is it going to be? No, it's just going to be I'm blanking out the name. Sorry, scan line. Sorry. So here, let me bring up the window again. Oh, this is from the other problem. Let me delete this. So I guess it's very close. Okay. So basically now you have a lot of different segments, right? You have pretend. Okay, that's terrible. All right, let's just. Well, I just wanted them to draw smaller, right? So now you have a lot of segments, and you try to figure out, how many of them are not overlapping. These are all overlapping, so that's kind of bad. But, you get the idea anyway. So then here, the way that I think about it is just scan line, right? So you're going from left to right, and then now, let's say you hit here, you go, okay, what is the furthest point that I have to, for this one, that all this has to be in the same segment, right? Same partition, sorry. And then now you go to the next one. Let me change the colors real quick, which is here, right? Well, here is saying that I have to be in the same partition all the way up to here. So then now we just extend this, right, to here. And then now the next, I guess, thing is here. Same thing. It goes to here. And then now it has to extend this. So it has to be on the same segment. So that's basically the idea, right? Is that you keep on extending, and then eventually you'll find one that's like, oh no, I am past, the thing. So then now I could create a new partition. Then now, so now you calculate the number of maximal partitions, say, right? What does that mean? That means that that this is the second part of the math, which I didn't find to be that difficult, but it could be whatever. But yeah, so let's say you have, 5 partitions, right? What does that mean? Well, one way to think about it, and that's the way that I thought about it during the contest, is that if you have 5 things, that means that you have 4 things in between, right? And if you have 4 things in between, one way to think about it is that each of these can be connected or not connected, right? So that means that if you have 5 partitions, you have 4 things with 2 choices each. That means it's going to be 2 to the 4th, and with some mod, but that's basically the idea. So that means that for n, for n partitions, you generalize it to n minus 1 or 2 to the n minus 1, keeping account mods. So that's basically the way that I did it. And once you do it, once you realize all these things, it's pretty straightforward. I actually don't even need to use first. I just thought that maybe I need to do something about this, but yeah, and I still did in 4 minutes, so you don't have to worry about the timing. But yeah, last is just the last thing, and we keep on updating with the last element. Maybe we go to count backwards, it doesn't really matter. But yeah, count is the number of partitions, and furthest is the furthest of the current partition, right? So then if the current index is further than the furthest, then we could start a new partition. Otherwise, we set the furthest to the last element of the current element, because you have to have that on the current partition. And then yeah, that's pretty much it. And then just return the power, as we said. This code looks pretty simple, but as we talked about, there's a lot of things to do about it and learning about it, and there's a little bit of maybe greedy about it as well. But yeah, that's pretty much all I have for this one. What is the complexity? I guess that's one more. It's going to be linear time, linear space because of counter, and yeah. And obviously this is linear time, this is linear time, and this is not linear time. But yeah, that's all I have for this one. Let me know what you think, and you can watch me solve it live during the virtual contest now. To mod anything? Let's give it some. Okay, good. Count the number of good partitions. If no 2 subarrays contain. Mod. N is big, so not DP. There are 8 possible good partitions. Still maybe DP. It feels very awkward for it not to be DP. If no 2 subarray contains the same number. So that means that all the numbers have to be in the same thing. What does that mean? So you have all these segments, and basically you keep on merging segments, and then what happens? And then it's just 2 to the number of segments. Is that right? Is it 2 to the number of segments, or 2 to the segments minus 1? I mean, whatever, the number of things in between. Okay, fine. How do I merge all the components? Right. It's okay. Okay. Whatever, just go count. Keep it short, Larry. You can just type it, and then we have a first. Last. Right before x in the way nums. First of x is equal to I, if x not in first, and last of x is equal to I, right? So then now, okay, for I in range of n, so okay, I guess we always have one component, so maybe I could just start off here, keep it as dumb. Furthest is equal to 0, maybe just give it there we go. If I is greater than furthest, then count increment by 1. And then something like, do I even need to first? Furthest is, you go to max of furthest, last of num sub I, something like this. Yeah, okay. And then now return pow to count -1 and mod by mod. Is that it? The inputs are kind of crappy. 812. Like this could very easily be wrong, and I don't 1212. So that should be 1, and then maybe 1 2 1 2 3 3 and 4 3. I don't know. It doesn't matter. That should be 2. Okay, let's just YOLO submit. Okay. Thanks for watching. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.